Welcome back, my dear students. This is Fluid Mechanics 18CV33 as per VTU Syllabus. Fourth module we are covering. In fourth module, there are two parts. The first one is Orifices and Mouthpieces. That's why I call this one as a 4a. And in second part, 4b. That is your notches and wears. Okay, that's why this is a first lecture in 4a, therefore 4a1. Right, we'll go ahead. Then as per VTU syllabus, this is the content given in the syllabus. That is, we need to cover introduction, classification of orifices first, and flow through orifice, discharge through orifice, hydraulic coefficients, numerical problems we need to solve. Then after that we'll come to mouthpiece and their classification and Borda's mouthpiece. For these two only we need to cover. Now you should understand what is orifice. Do you know what is orifice? Orifice means a small opening. Small opening is called as orifice. Wherever it might be, if you take a CD disc, disc you have seen. See, this is a small opening. That is orifice. You can take something, some arrangement like this. Some arrangement is there here. Small opening is there. Then this is your orifice. Okay, now orifice means what? Small opening. But here in fluid mechanics, where we see this orifice, let us consider this is a tank. This is a tank, and if a water is coming from here, means you have made some small hole here, then so that the water is coming out of this. Then I can call this is the orifice. Then it is side of the tank, therefore side orifice. You can make that small opening even at the bottom also. If you make a small opening here, then the water will come. You know? That is also orifice. Even you take a pan and pan has some small hole here, then that is your orifice. Okay, it's not big deal. Orifice means a opening. Why openings are provided in the tank? To discharge the water. To discharge the water, we are providing orifices. Right? Then what is mouthpiece? Mouthpiece is also a opening, but a small extension will be there in the structure. See, let us consider this is a tank, and if I provide this opening, now here is a opening, then I will call it as a orifice. If I provide small projection in the opening, the purpose might be different. Why we have provided this projection, we have many reasons for that, but you just concentrate on, if we have a projection, that is a mouthpiece. If you don't have a projection, then that is orifice. Understood? Then the function of these two are same. If a water is stored here, then orifice or mouthpiece, they will discharge water. Okay, they will discharge water. Now in this chapter, our job is, first we need to understand what is this orifice, a small opening. What is this orifice and how many types of orifices are there? That is your classification of orifice we will study, and later we will study how much quantity of water it can discharge. For that we need to find the expression, and if at all a water is coming here, water jet is coming here, what is the velocity of this water jet? Okay, this one we need to study. Here, for this study, we will divide into two parts. The first one, theoretical study, and the second one is practical study. Okay, means what? Theoretical discharge and theoretical velocity. Like that, practical actual discharge and actual velocity, because they will be differing. I will tell you why. Right? This is what it is involved in this fourth module, A part. Right? We'll go. Now I already told you what is orifice. If you want a definition, it's very easy. The orifice is a small opening. I told you, small opening of any cross section. Any cross section in the means that small opening can be a circular opening or it can be a triangular opening, either this shape or this shape, whatever the shape, triangular opening, or rectangular opening, okay, or square opening, or semicircular opening, or oval type opening, or this opening, okay, whatever the cross section may be, a small opening is called as orifice. Once again, orifice is a small opening of any cross section such as circular, triangular, rectangular. On the side, okay, it can be on the side or at the bottom of the tank, right? See, the orifice can be in the sides or it can be bottom of the tank through which fluid is flowing. Why we are providing this orifice? To discharge the fluid. Understood? Then what is a mouthpiece? Mouthpiece is a short length of a pipe. See, this is a pipe, this is a pipe. Then short length of the pipe. Short length means what? If this diameter is d, then we will take only 2 to 3 times of the length d. If it is 2 to 2d or 3d. If you cut that pipe, then what you will get? You will get small pipe. This small pipe, what will do? We'll put that small pipe into this tank and we'll make it open. Then it becomes what? Mouthpiece. Understood? Means it has a little projection compared to orifice. Okay. Then mouthpiece is a length of a pipe which is 2 to 3 times its diameter in length, fitted in a tank or vessel containing the fluid. Then orifice as well as mouthpiece are used to measure the rate of flow. Right? And again, the mouthpiece may be side or it can be bottom. Understood? This is a definition of orifice and mouthpiece. Hope you understand. Now we will study only orifice, classification of orifice, and later after studying entire things about orifice, we'll go to mouthpiece. Then in this classification, we can make the classification based on many parameters. The first one I will consider large or based on size. Okay, classification based on size. Okay, classification based on size, we have a two type of classes here. The one is a small orifice and the second one is big orifice. Okay, now small orifice and big orifice I cannot say by seeing diameter. Say for example, if I have a 10 mm diameter, then a small, then it is a 1 meter diameter, then it is a big. No, like this we will not say. Okay, we don't have any criteria to say it is a small or big by mentioning its a dimension. No, here we need to compare the head of water for particular orifice. Say for example, I have one very big dam. Okay, I have very one big dam is there here, and let us consider this big dam is of about 50-meter height. Then I am providing one small opening to this dam, small opening to this dam, and this dam opening is 1 meter diameter. Okay, then for this entire dam, this 1 meter is a small, no, it's very small, but that 1 meter may become very big opening for a particular tank. If the tank height is about 2 meter, then the same opening, 1 meter opening, may be a very big orifice for the tank. That's why here classification of orifice we have to make it like how? We need to consider if the tank is there and this is your orifice opening, this is your opening, and we'll consider the center of the orifice and we'll measure the water storage here. We'll measure water storage here. Let us call this is the depth of orifice. In circular it's a diameter, it is a depth of orifice, and this is a height of water that standing for the orifice. Now, if this h is greater than 5 times diameter or depth, then I can call this orifice is a small orifice. Then the reverse, if h is less than or equal to 5 times diameter, then that orifice is called as a big orifice. Write it down here. Small orifice means if the depth of the orifice is less than 5 times the height of the tank. Now write it down. Small orifice means the height of water measuring from center of the orifice till the free surface of the liquid is greater than 5 times depth of the orifice. Okay, then coming to big orifice. Big orifice means what? Here the head of the liquid from the center of the orifice to the free surface of the liquid is less than or equal to 5 times depth of orifice. Okay, that is your smaller big orifice. Okay, the second classification is based on cross section. Based on cross section. Cross section. Now, you already know we have circular orifice, circular orifice, circular orifice. How it look like circle. Then second one is triangular orifice, triangular orifice. It look like triangle. Again, the triangle may be different shapes. Maybe we may have. Okay, triangular orifice. The third one is a rectangular orifice, and the fourth one is a semicircular orifice, semicircular. Like that you can write many names for the cross section, and you can have opening for them, right? This is the second classification. Then the third one is based on shape of upstream edge. Okay, see here, this is a tank and this is a orifice, right? This is a orifice. Then here this is called as upstream side and this is called as a downstream side. Then upstream side edge, how it is? If it is very sharp, then this edge is very sharp. I will zoom this part and I will show you. Let us consider if the tank is coming like this, then upstream edge is very sharp, either this way. Okay, now see, this is the tank. Now the upstream edge is very sharp. Then the first classification is sharp edge orifice. Sharp edge orifice. Okay, not only this one, you may have like this also, one side, and see, this is also a tank and this is the opening. Okay, like that you can have a sharp edge orifice. The second one is bell mounted orifice. Bell mounted. Bell mounted means inside edge is somewhat bent. Here a little bent is made here. How is your bell? Bell will be like this now. Okay, the same thing, a little bend is made here so that you will be having opening. That is bell mounted orifice. This is based on shape of upstream edge. Next we will come to the fourth classification based on nature of discharge. Nature of discharge. Nature of discharge. Then how the discharge is coming. Say for example, the first one we have free discharging orifice. Free discharging orifice means this is the orifice and water comes here and freely fall it down. We don't have any barrier in this discharge. Okay, this is a free discharge orifice. And the second one is submerged orifice. Submerged orifice means what? That particular orifice is submerged here. We have another tank here, and here the depth of water is more and here depth of water is less, so that the water is coming here, but this orifice is submerged, therefore submerged orifice. This submerged orifice may be two types. It might be fully submerged, fully submerged, or it can be partially submerged. partially submerged. These are all the classification of Orifice. Okay. Thank you, dear students. In the next class, we will derive an expression for discharge through Orifice. Thank you.